Now we're going to find the inverse of a function, and before we move on to our lesson for today, you need to first know how to perform some polynomial operations to be able to find the inverse of f of x. You also need to know how to graph some basic functions and of course to solve equations. Now inverse of a function is given by this notation. Let's say we have f of x. To find its inverse, we're simply going to find f to the negative 1 or f inverse of x given by this notation. So f of x is the function of x, and f raised to the negative 1 is our inverse function of x. Now to put it in perspective, let's say we have a relationship between the values of x and y as our f of x given by this function. So the function is in table form, so our domain, which is the values of x, and the range, which is the value of y, are given by its table. And to find the inverse of a function given this table, we simply have to interchange the value of x and the value of y, and we'll be able to find the inverse of the function. So our x is now going to be y, which is 5, 2, 1, negative 6, and negative 2. And our range of values will be the x value of our f of x, which is negative 2, negative 1, 0, 4, and 8. So this is how we relate the inverse of a function given the relationship of x and y in table form. Now how are we going to translate this in finding the inverse of a function given its equation? So in our first example of a function 2x plus 7, we're going to be using algebra in finding the inverse of this function. So to find the inverse of f of x, the first step is to rewrite our function form into y function. So instead of writing f of x equals 2x plus 7, let's rewrite it as y equals 2x plus 7. And then the second step is to interchange your x and your y. So your new function will become x equal to 2y plus 7. And the third step is where we're going to be using algebra in solving for the value of y, or isolating y in our function. So let's go ahead and perform step number 3 using algebra. So to find y, or to solve for y, the first step that we're going to be doing is to subtract, or to get rid of the constant. So we're going to subtract 7 on both sides, leaving us with x minus 7 equal to 2y. And by getting rid of 2, we will divide both sides by 2, leaving us y by itself. And now we have the inverse of our function, which is x minus 7 all over 2. So this is how we use algebra in solving for the inverse of a function given its equation. So f inverse of x is x minus 7 all over 2. Now let's go ahead and answer problem number 2, given by a radical function square root of 2x minus 3. So the first step is to replace our f of x with y. So now we have a y function which is equal to the square root of 2x minus 3. And the second step is to interchange our values of x and y. So now our new function will be x equal to the square root of 2y minus 3. And from here we're going to be using algebra to solve for our y function by performing 2 or more steps. And in this case, our first move would be to raise both sides by the power of 2, so we can get rid of the square root with y. So by canceling our square root with square, we are left with x squared equal to 2y minus 3. And to have y by itself, the next step is to add 3 on both sides. So our new function will simply be x squared plus 3 equal to 2y. And by dividing both sides by 2, we'll have x squared plus 3 all over 2. So our inverse function is given by x squared plus 3 all over 2. And we're able to solve this by using algebra. And for the third type of function that we're going to be solving, we're going to be working with a graph. And to find the inverse function of f of x given its graph, all we need to do is to reflect our function f of x, or f, into the line y is equal to x. So let's say we have a graph given by this function, which is the red graph that you are seeing right now. So to find the inverse of this function, notice that we don't have the equation nor the values of x and y. We're going to be using our graph in reflecting it along y is equal to x. So the diagonal line that you're seeing is the function y is equal to x. And to be able to reflect our function easily, we're going to use the 3 points that we are seeing right now, and we're going to find its ordered pair, starting with the first point over here, which is -3 and -2. And just like what we did from the previous examples, we're interchanging the value of x and y to find the inverses. We're going to be doing that as well in this graph. So if we interchange -3 and -2, we'll have -2 and -3, which is the inverse of that particular point in our f of x. So this is our inverse function, or one of the points in the inverse function, which is -2 and -3, and we're going to place a dot on that particular inverse. So the next point that we're going to be using is this point over here, which is -2 and +2, and the inverse of that point would be +2 and -2, which is here on the fourth quadrant. So the fourth quadrant will give us the second point that will help us graph the inverse function of our f of x. And the third point that we are seeing on our red graph for f of x is at 4 and 1, and its inverse is 1 and 4, which is also on the first quadrant. So now that we have our 3 points that we can connect, once we connect the dots, we'll be able to see the inverse function of our f of x. So the red graph that you are seeing is our f function, and the blue graph that you are seeing right now is our f inverse function, which we are able to generate by referencing the points that are given, that were given in this graph of x. Now in the second example, we're going to be working with a smooth curve, and notice that we are not seeing any dots or points in our function. So what we're going to do is we're just going to estimate or approximate the dot by plugging in or finding points on the f of x that would help us find its inverse. So the line that we need to reflect our f of x on would be our diagonal line, which is y equal to x. And we can start with this endpoint over here for the first point of our function. The first point that you're seeing is at 1 and 0, and we will use that later on to find the inverse of our f. Now the next point that I will assign will be at this point over here, which is approximately at 2 and 1, and I can also add another point over here, which is at 5 and 2. So given that the ordered pairs of 1 0, 2 1, and 5 2, we'll be able to find the inverse of a function by plotting the points across the line y is equal to x. So our first reflection of 1 0, finding its inverse, is going to be 0 and 1, which is going to be at this point in our xy plane. And 2 1 will give us 1 2 for its inverse, and it's going to be somewhere here in our Cartesian coordinate. And for the last point that we will use so that we can sketch the graph of our inverse function, we'll have 2 and 5, which is somewhere over here in your first quadrant. And by connecting the points in our inverse function, you'll be able to see the graph of the inverse function of f. And this is how we solve for the inverse function of f of x given its graph.